Hello, hi, this is Arvind Singh. I'm going to give the introduction about software engineering in this video. So, the learning objective of this video is definition of software engineering, software development lifecycle, software engineering models, what are the different software engineering principles. Then we cover design and architecture of software, tools and technologies that we use for developing the software, what are the challenges in software engineering, and lastly we'll end with the futures of software engineering. Let's first get the definition of software engineering. I think all of you are aware what is software. Software is nothing but a set of programs. And what is program? Program is nothing but set of instructions that we give to computer. So software engineering definition is very simple. To make the software, what we follow, that is, it is a systematic, scientific and disciplined approach towards development, maintenance and functioning of the software. Next we'll see what is development life cycle of a software. Every software follows a development life cycle. Number one, we'll go for requirement gathering and analysis phase. In this phase, we gather requirement from the customer and we analyze the requirement, how we are going to proceed with the requirements that we analyze in this phase. Second phase is designing of the system. In this phase, we'll design the requirements that we have taken from the customer in GUI form. Third phase is implementation phase, where we select any one of the technologies and we do the coding over here. Next phase is testing. Once the implementation phase or coding phase is done, we test. Either we test it through the third party or from the itself, from other than the code who has written the code. Testing shows there are bugs in the software or not. So testing plays very important role in development life cycle. Then once the testing is done, we ensure that everything is proper. We deploy our software at the client end. Next we have maintenance and support. This phase is about once a software is built, it is now going to provide the solution to us and we are having support in terms of new features. If customer have any issues while using the software, so this part is going to be helpful. So these are the phases of any of the software development life cycle. Whenever we are developing any software, we have to follow this life cycle properly. So next is what are different engineering models. Models means what? How we going to build the software, what is the view of the software. So we follow different models for that. One of the model, which is the oldest model, it is waterfall model. Okay, so in this I have just mentioned about what is the type that it belongs. It is best suited for what? When we are going to use waterfall model, we have advantages and along with we have disadvantages of using this model. See, every model will have some advantages and disadvantages. So throughout this video, I have tried to mention some of the advantages and disadvantages. It's which kind of category it follows and when it is suited for what. So waterfall model is the linear sequential model. It is best suited for where you have stable requirements, well defined requirements. Advantage is it is easy to manage, it is very simple. Disadvantage is it is inflexible, changes are difficult in any, because once the changes will come from the customer, we have to start from the phase 1. Okay, now next we have V model, verification and validation model. We call it as V model. It is a type of sequential model. It is best suited for the projects which have require strong testing. Advantages: it covers emphasizing testing, because testing is very important over here. Disadvantages: rigid, costly for changes. Next, we have agile model. So agile model is a type of iterative model. It is best suited for the projects with evolving requirements, where the requirement of the customer is changing. So we use such kind of model over there. Advantages is flexibility, customer collaboration. Disadvantage is it is complex for the large teams. So when we involve the customer in our software, because we are making software for the customer is very important for us. So in agile model, we involve customers. In next part, we are covering spiral model. It is type of iterative model. It is best for where we require high risk, large projects. Advantage in this, we have managing the risk over here. Risk management is very easy to manage in this model. Disadvantage is it is complex, it is costly. Next, we have prototyping model. It is also a type of iterative model. It is best for the small to medium sized projects. The advantage is flexibility, faster feedback, early user involvement. Disadvantage is incomplete requirements, limited scalability. RAD model. RAD model is a type of sequential model. It is best suited for the medium to small size of projects. Advantage is rapid development, improved quality. It is disadvantage is less suitable for large projects, because we require high user involvement in this model. Next, we have software engineering principles. So principles are nothing but the foundational guidelines and practices that are required to design the software engineer, to develop it, and to maintain high quality software systems. So when we have the principles, so we are following these things like reliable, it is maintainable, scalable, and adaptable to change. Software is reliable, maintainable, scalable, and adaptable to change. So we have some principles listed over here. Number one is modularity. Modularity means to break the software into smaller modules. Abstraction, hiding the features, hiding essential features and hiding the features that we don't want is abstraction. Separation of concerns means we divide the system into distinct sections so that task will be completed in a proper manner and proper time. Reliability. Reliability in terms of software works correctly under the various conditions. Maintainability. So when we talk about maintainability, it can be easily modified, it can be extended, and in future it is debugged very easily. Software design and architecture. Design part is very important part of the software, because user mainly focuses on the design part. Definitely design and architecture is going to be very important for all. So here also, the first we will cover what is the design. So in design, it is a process of defining the structure, component, interfaces, and their interactions in a software system. It focuses on how individual pieces of the system will work together to meet functional and non-functional requirements. Software design ensures that software will be efficient, maintainable, and adaptable to change. So we have listed some of the aspects of software design over here: component design, interface design, data design, algorithm design, and user interface design. Next, we cover software architecture. In software engineering, it is referred to high level structure of the software system, focusing on how its major component or module are organized and how they are going to interact with each other. It provides an abstract, it's a blueprint that guides the design and the development of the system, ensuring that it meets both functional and non-functional of the requirement. So such as non-functional requirements are scalability, performance, maintainability, and security. Some of the key aspects of software architecture are component or modules, examples like services, classes, or microservices. Interaction means APIs, messaging system, patterns and styles like uh, layered architecture, server, microservices, event driven, and MVC, model view controller. Technological decisions like database, framework, programming languages, and quality attributes like performance, security, scalability, reliability, and availability. In next slide, we cover about what are the tools and technologies that we are going to use for software engineering. First, we have categorized in different environments. First environment that I'm going to cover is IDE, Integrated Development Environment. So if I'm using IDE, then I will use any one of the software as per our requirement. Any of the tools or technologies we can use like Visual Studio, Eclipse, PyCharm for Python, Android Studio for mobile applications program. Eclipse we can use for the Java, and Visual Studio for .NET kind of applications. Then we used tools and technologies like database and data for managing database and data management, MySQL, Firebase, Oracle DB, MongoDB. Then we have now cloud computing platforms. We use such kind of tools like Amazon Web Services, Microsoft Azure, Google Cloud Platform, and IBM Cloud. Then front end development technologies, I can go for HTML, CSS, JavaScript, React, Angular. Now for backend development, we can go for Node.js, Django, Spring, Ruby. And some of the security tools are also available like Wireshark, SonarQube, OSAP, JAP, HashiCorp, Vault. So these are the tools and technologies that we have covered in this. Now next, what are the challenges that we face in software engineering? The first one is during requirement and gathering analysis. This is the very difficult task because gathering all the requirement from the customer is very difficult. Next, managing changing requirements. Since requirements are changing in a project very frequently, so without proper assessment, it is very difficult to manage the requirement. Time and budget constraint, balancing the quality with limited resources is very challenging factor in software engineering. Ensuring software quality, maintaining high performance, security, and reliability is one of the challenge factor in software engineering. Dealing with the legacy system, as many of the softwares are outdated, but still company use it because they are very familiar with it. They are not going to adopt the changes in that. So it is also one of the challenge. Then we have security vulnerabilities, preventing cyber attacks and data breaches. Team communication and coordination among the team members and the stakeholders is sometimes very difficult to manage. This is also one of the challenge that we face. Resource management and skill gap, finding the right skills and the tools is also one of the challenge. Testing and bug fixing the bugs, identifying and resolving the software bugs is sometimes very difficult. Keeping up with the technology, as rapid advancement in the tools and the frameworks in industry, so it is very difficult to cope up with all these tools and technologies in very short period of time. So this is all have the challenges that we have to face uh, while doing the software, making the software for clients or customers. The last topic that I'm going to cover is futures of software engineering. So what is the future of software engineering is number one, AI and machine learning in software development, which is a very fast growing technology everywhere in the world. Second, low code and no code development kind of things in future will cover cloud native and serverless computing technologies. We are going to have the future. Then quantum computing and software engineering, then blockchain and decentralized applications, edge computing and IoT integration, then cyber security and privacy first development, DevOps and continuous integration or development, then sustainable and green software engineering, and lastly software engineering in education and continuous learning. So I hope this will find suitable for you, and most of the concepts of software engineering I have covered that is in this video. So thank you so much. Thank you.